If you want to see how I made a computer go from this, a model that barely recognized a quarter of all the heroes, to this, a model that recognizes over 3/4 of all the heroes, then stick around to find out. It all began 70 days ago, on January 1st, when I made a New Year's resolution to study machine learning. After 50 days of doing courses and building smaller projects, I wanted to take on something big. So I challenged myself to fine-tune YOLO to recognize every Marvel Rivals hero. If you don't know what YOLO is, it stands for You Only Look Once. It's an object recognizer. Think of it as a computer's eyes, allowing it to detect and see things in real time. Before I dive into how I built the model, let me first explain the evaluation metrics and training code. A bounding box is what the model places over recognized objects. Obviously, it will look like a box, hence the name. Now let's go over metrics. Precision is a metric used to know how many detected objects, heroes in this case, are actually correct. For example, let's say Wolverine is on the screen. The model detects Wolverine and gets it right. This would then allow for the precision score to increase, but if the model incorrectly recognizes Wolverine as Black Panther, the model's precision score would decrease. On to number 2, recall or R. Recall is a metric used to understand how many of the actual objects did the model predict correctly. For example, let's say there is a Penny Parker, Spider-Man and Venom on the screen. If the model recognizes all the heroes on the screen, the recall score will go up, but if it doesn't recognize all the heroes, the score will go down. Now on to map 50 and map 50 to 95. Map 50 means the model's detected bounding box for an object needs to overlap with at least 50% of the actual object's location. Suppose the model is detecting Spider-Man in a match. If it places a bounding box around Spider-Man, but it's slightly off center, maybe covering his top half but not his bottom half, the detection still counts as correct because it meets the 50% overlap requirement. Map 50 to 95 is different. It's a stricter evaluation, requiring the model to be more precise across multiple levels of accuracy, from 50% overlap up to 95% overlap. If the model detects Spider-Man but the bounding box is too loose, including extra background space or cutting off his feet, it might pass the 50% level but fail at 75% or 95% levels. Now that I've explained what the 4 metrics mean, let's go over my training code. Training code and acknowledgements. First off, I'd like to extend a big thank you to Edge Electronics on YouTube. His YouTube video, How to Train a YOLO Object Detection Model in Google Colab, was my main source of information for getting this project up and running. His video provided me with the training code, data labeling instructions, and a handy Python script that the background gameplay of this video uses. I tweaked Edge Electronics' original code to fit my local training setup better. In particular, I wrote a custom Python script that automatically splits my dataset into training and validation sets straight from local folders. No need for RoboFlow or manual splitting. I also set up the data.yaml file to be generated dynamically from my custom classes.txt, which makes it easier to manage class definitions and really streamlines the whole training process. Now that I've explained my changes to the original training code and the 4 metrics, let's dive into the meat and potatoes of this video, the data collection and training. For each part, there will be background footage of that YOLO model working in real time on the game Marvel Rivals. Part 1 of training. At first, I collected 400 images of in-game screenshots from the replay viewer in Marvel Rivals. I took the screenshots by using the Xbox game bar, Windows G, to take screenshots manually over the course of a few matches that I played. After I did that, I went and installed Label Studio, which is a labeler that I will be using to label the images. I then put the 35 hero names into the labeler, and using bounding boxes, I labeled each hero accordingly. This first part of the data collection took 4 hours. Now onto the exciting part, the training. I started with Yoli 8 Nano and fine-tuned it on 50 epochs. Once the model was fully trained, I received the 4 metrics. For the map 50 score, I had a score of 0.336 and a map 50 to 95 score of 0.195. For the other 2 metrics, precision and recall, precision had a score of 0.449 and recall had a score of 0.301. The results revealed a truth that I didn't want to hear, and that was that I needed to collect more data. Looking at the results closely, we can see which heroes have the highest map scores and which heroes have the lowest. In no particular order, the highest map scorers for this training round were Venom with a score of 0.995, the Punisher with a score of 0.995 as well. Some of the other highest scorers were Lunar Snow with a score of 0.931 and Cloak and Dagger with a score of 0.835. For the highest scorers, Venom and the Punisher, they each only had 1 image for the validation phase compared to the other highest scorers such as Lunar Snow who had 12 images and Cloak and Dagger who had 13 images. This means they had an underrepresented amount of data in the validation set. The lowest performing heroes were Black Panther, Doctor Strange and Thor, each with a map 50 score of 0. This was likely due to the same issue that caused Venom and the Punisher to have a near perfect score of 0.995, insufficient images in the validation dataset. However, unlike Venom and the Punisher, the model failed to recognize these heroes at all, resulting in a score of 0. Part 2 of training. Now for the second part of data collection and training. I needed to collect more images of each hero so the model could generalize better. Luckily, I had already created a dataset that I had used to make an image classifier. The dataset had 35 classes with 15 images for each class. After I reorganized the data, mostly changing the file names so they weren't the same, I uploaded the images to Label Studio and started labeling them one by one. This second data collection part was much quicker than the first part, as all I had to do was label the data. It took 2.5 hours. Now that the data had been labeled and put into the training data folder, I started the training with 50 epochs. Once the training was finished, I checked the results and got a map 50 score of 0.364, which is around a 3% increase compared to my first training, and got a map 50 to 95 score of 0.205, which is only an increase of 1%. For precision, I got a score of 0.587 and recall got a score of 0.295. The classes that did the best in this training round were Lunar Snow with a score of 0.989 and Cloak and Dagger with a score of 0.185. The model was getting better, as there was only one hero that scored a score of 0, and that was Doctor Strange. Unfortunately, I had made a mistake with the validation set and didn't add any new images to it, which means the model was using the validation set from part 1 of training. This makes sense as there are 2 heroes with 1 image each in the validation set, and those 2 heroes were Venom and Doctor Strange, which were the same 2 heroes who had 1 image in part 1 of training. The heroes who had a low map 50 score were the same as part 1 of training, Black Panther and Thor. Apart from those 2, we had Captain America with a score of 0.023. The results from this training round suggest that most, if not all, the heroes still need more data, and the validation set needs an update when I collect the next lot of images. Part 3 of training. Onto the third part of training. as the results of the last training one indicated that the model still wasn't performing well. So you guessed it, I had to collect more images. This time, I collected up to 650 in-game screenshots, but I did do it manually by using Xbox Game Bar. Instead, I used ChatGPT to make a Python script that would automatically screenshot the game every 5 seconds. This made the data collection process a breeze. The screenshotting script is in the Hugging Face repo, which can be found in the description. Now onto the tedious bit, the data labeling. This set of data labeling effort took around 6 hours spanning across multiple days. Yes, multiple days. Data labeling is such a slog. As Vernie Coleman would say, everyone wants to be an ML engineer, but no one wants to label this heavy ass data. Before I got to training, I made sure the validation data was updated according to the updated data, which means there are approximately 150 images in the validation dataset this time, compared to the 30 images of the previous 2 training sets. But now onto the training. I was fine tuning YOLO 8 Nano again, and this time I was training it on 50 epochs. This training was a great success, getting a map 50 score of 0.606 and a map 50 to 95 score of 0.449. Precision had a score of 0.821, and Recall had a score of 0.497. These scores indicate that this training run was hugely more beneficial than the previous training run. This makes sense as I had updated the validation data and added 650 images. The heroes with the highest map 50 score includes Hela with a score of 0.995, Loki with a score of 0.995, and Psylocke with a score of 0.890. Not surprisingly for this training run, no heroes got a score of 0 like the previous training runs. For the lowest scorers, we had Black Widow with a score of 0.8080, Jeff with a score of 0.080, and Iron Fist with a score of 0.299. These scores indicate that the model is learning well and is understanding what the heroes look like. But of course it did have its own problems, such as the high scorers Hela and Loki. The 2 Asgardians only had 2 images each in the validation dataset compared to other heroes who had up to 20 images. This is good because it tells me who I need to collect data on. Part 3.5 of Training. Why is this called Part 3.5 of Training and not Part 4, you might ask? Well, let me tell you. This is because I didn't update the data at all and only changed the model size. I went from YOLO 8 Nano to YOLO 8 Medium as I wasn't happy with the recall that Nano provided. Onto the training. I only trained the model on 25 epochs this time instead of 50, as the metrics stopped going up at around 25 epochs and actually went down slightly. The model took significantly longer to train. Nano took around 2 hours for 50 epochs, and Medium took around 4 hours for 25 epochs. The learning rate was the same for both. Once the training was complete and I got the results, I was pleasantly surprised. The map 50 score was 0.749 and the map 50 to 95 score was 0.521. For precision, I got a score of 0.839, and for recall I got a score of 0.607. This was a significantly leap for the scores, with an increase of 14 for the map 50 and an increase of 7 for the map 50 to 95. And recall also increased as well, going from 0.497 to 0.607, which is an increase of 10. The heroes that achieved the highest map 50 score were Black Panther with a score of 0.939, Mr. Fantastic with a score of 0.904, Winter Soldier with a score of 0.918. For the lowest map 50 scorers, we have Black Widow with a score of 0.332, Jeff the Landshark with a score of 0.497, and Moon Knight with a score of 0.511. Final part of training. For the last part, I needed to get more data for underrepresented heroes. How I did this was I checked my validation graph at the end of part 3.5 of training and checked what heroes needed more images. Then once I had the 6 heroes I wanted to get more data on, I made a custom game with bots and Marvel rivals, and each team was allotted the same heroes, and those heroes were Black Widow, Hela, Jeff the Landshark, Loki, Magic, and the Hulk. After I played the game, I got the screenshots using a Python script from part 3 of each hero on my team. Then I went into Label Studio and started labeling the images. This labeling effort took 2 hours for around 200 images. I then did the same process for the heroes of Groot, Hawkeye, Iron Fist, Iron Man, Mantis, and Moon Knight. This time labeling took 3 hours as I had 350 images. For the final part of training, I was experimenting with model sizes again, and this time I trained a YOLO 8 Nano model and a YOLO 8 Large model. Our main focus for the final part of training will be the Large model, but the Nano model is available for download in the Hugging Face repo in the description. The training took 11 hours and 45 epochs for the Large model. Now for the metrics. The Map 50 score got a score of 0.813 and the Map 50 to 95 got a score of 0.569. Recall got a score of 0.667 and Precision got a score of 0.887. The heroes with the highest Map 50 were Jeff the Landshark with a score of 0.971, Captain America with a score of 0.948, and Hulk with a score of 0.946. It was clear that the model was performing better on Vanguards compared to Strategists or DPS. This makes sense as tanks are usually much larger than the other two heroes, so the model has an easier time recognizing them. For the heroes with the lowest Map 50 score, we had Adam Warlock with a score of 0.504, Namor with a score of 0.738, and Penny Parker with a score of 0.621. When I took a look at the results table more closely, I noticed that they didn't have many validation images compared to the rest of the heroes. So we can guess that these were the last classes that had underrepresented data for their classes, dragging their metrics down. Conclusion. And it looks like I've reached the end of this presentation. Now let's go back and have a quick recap of all that has happened so far. When I first started, the first model was trained on a tiny dataset of 400 images. Accordingly, the model didn't do so well, only receiving a Map 50 score of 0.336. The second training, where I was hoping the model would generalize better on some old data that I had created for a classifier, as I found out later in part 3 of training, I didn't update the validation data, so the metrics didn't do the model full justice, receiving a Map 50 score of only 0.364. Onto the biggest jump of performance yet, part 3 of training. After adding more than 650 images of data and fixing the validation dataset, I got a Map 50 score of 0.606. Then remember when I decided to finally experiment with model sizes, increased my Map 50 score by 14 from 0.606 to 0.749, a huge increase for just changing the model size. And finally onto the last part of training, where I got more data for underrepresented classes and changed the model size from medium to large with a final score of 0.813, which was trained on 1900 images. Now that I've done a recap for this entire project, I would like to list some improvements that I could do next time. The first improvement would have to be organized data collection similar to the final part of training. If I had collected data for underrepresented heroes all the way through, I most likely would have sped the process up and gotten better metrics as well. The second improvement is minor but important, and that would be switching the game's graphical settings to high or medium compared to low. This could have potentially increased all the metrics, with high quality clearer data, especially the recall. Another one I had is that I could have used data augmentation such as flips and rotations and hyperparameters such as learning rate or batch size. And those were the improvements I had for the project. If you guys have any other improvements, let me know in the comment section down below. And this is where we part ways, you and I. If you liked this video, give it a thumbs up, and if you want more of this content, subscribe to the channel, where I'll be updating you all on my machine learning journey with more fun projects. If you want to play around with any of the models, the training code, the screenshotter, or download the data to make your own model, it will all be down in the Hugging Face repo below in the description. Goodbye and good night everyone.